Welcome to the lab. What you came here for is a video concerning a hydrogen electrolyzer. Now, why would anyone build a hydrogen electrolyzer, you might ask? Well, I'm not saying that it's going to replace gas in the overall energetics network, but it's being implemented nowadays and it is useful for some things. So, for instance, as an energy storage in kind of like residential houses, perhaps, or in industry, you can burn hydrogen and stuff. So I'll walk you through how easy it is to actually build a hydrogen electrolyzer from pretty much stuff that you can find laying around. To be fair, I'm definitely not the first who's built one. There are tons of videos on YouTube that I recommend that you watch, and all those are great. It's just that I built a I built a different design with the cylinder stainless steel tube as the body and the electrode going in from the upper side. Now, what you should be aware of is that this design produces HHO, and it's a little different to clean hydrogen. And the difference is that the HHO is kind of explosive. So be careful if you're, well, now you know, so you can make one. But anyways, what I'm trying to point out is that there's also a different design with a membrane which divides the volume around the anode and the cathode. But the membrane used is quite expensive. In fact, it costs like $100 for a tiny little piece, and I wasn't able to get one. So now I built this standard design, and I'm gonna show you how. Ready? Let's walk you through that. Now, I had this project laying around on my table for quite some time, so I'm glad I finally got to do it. Anyways, first I drew this kind of design with the cylinder thing. I hope you can see it, but then I made it kind of differently. Anyways, so that's can go to thrash. What I wanted to say is that this is what the membrane design should look like. There should be a membrane. It's called FAAM membrane, and it should be actually conductive for protons and gas proof so that the gas cannot go through. That would be very nice. However, we didn't have that. I already mentioned that. So in any case, hydrogen is produced at the negative electrode, meaning at the cathode. One other thing, material used. Literally, we should be using platinum. We don't have that, unfortunately. Instead, we're using stainless steel, mostly. I think some of the washers are zinc. At best, using platinum because even with stainless steel, the electrolyzer will just eat it up very slowly. I mean, it's okay if you're building one for testing or something, but if you plan on, using this for years, you might want to use platinum, which again is kind of expensive. If you don't have platinum, 316 stainless steel is the best solution for that. And now, in order to estimate or model the hydrogen mass production in kilogram per time unit, let's say per second, we can use the Faraday's law, which looks as follows in this case. We will multiply the current running through the electrolyzer times the molar mass of hydrogen, which is 0.002 kilogram per mole, times the efficiency of the electrolyzer, all divided by Z, which is 2 in terms of hydrogen because of 2 molecules, and the Faraday's constant, which is 96.45 coulomb per mole. Now, what comes into play to the efficiency is
actually the design of the electrolyzer, meaning the area of electrodes and potentially ions in the electrolyte, the shape and other things. When it comes to checking the units, on the left side we've got kilograms per second, on the right side the moles cross themselves out. The coulomb is basically amp times second, and as we look at it now, the amps can cross themselves out, and what we're left with is also kilograms per second, so this is verified.
Yeah, that's it. At this point, I thought I had won. The electrolyzer was there, wasn't it? Well, but for one detail in particular, that was that I needed to weld the cylinder to the plate. And at this point in time, I had just started learning how to weld. Well, I thought this is a great opportunity to practice and utilize my skill, wasn't it? You'll see how it went. Now, please don't judge me. I know you might have guessed, if you're familiar with welding, that using stainless steel electrodes for this kind of thin stainless steel would not be a great idea, but in fact I did try it and
Holy smokes.
just burned through. So this attempt was not a success. At this point in time, I decided to invest some finances into this project, and that was by buying a stainless steel flux core wire, which should be suitable for using it without any shielding gas. Perfect for me. And my hypothesis was that I could actually make this weld with that. Well, as you can see now, I managed to actually weld the threaded rods to the plate, which was a success and a breakthrough in a way. At the same time, I actually managed to fit the cylinder in between the welds, which was a sign that it was ready for me to try welding the cylinder with the flux core wire. What do you think? Did that work?
This time I was smarter, and to prevent the material burning through, I used some backing material.
although the weld seemed quite okay to me, I suspected there would be a catch.
Okay, test one, but I think this is gonna still leak. Let's try. Put some water in. There definitely leaks here. Yeah. At least we cooled it down. There's one huge leak.
So yesterday's attempt was not a success. In fact, this is what's left. I tried welding it with the stainless steel flux core wire, so without gas. And although I was initially happy with how it looked on the surface, as you've seen when I tried filling it with water, it just didn't seal at all. And so I tried a couple of times to grind away the weld and weld it again, but I just wasn't able to make it seal. And so in the end, actually, I managed to kind of screw up this plate. This is what's left. So although I theoretically could cut off this area here, and I could pretty easily make a new plate based on these dimensions and shorten the electrode. So theoretically, the design is still possible. I just don't know how to make that well happen. And so for one, the solution might be to use TIG, which would probably be more suitable for this kind of thin metal. When I measured it, it was somewhere between 0.6 to 0.9 millimeters, so less than 1 millimeter. That's really thin. This one is thicker, but like joining these together with the flux core that I have, and with the welder I have, and with the skill I have, just seemed impossible yesterday. And so I now have to come up with another design that does not require welding a cylinder to a flat surface like this. Wish me all the luck.